right? So what is the advantage of the Databricks is because these three reasons that are you are seeing in the screen, these three reasons because of which we are basically trying to use the Databricks. One thing is productive. Productive means so internally within the Azure Databricks, so that we will see, we will be creating the clusters. Okay. So clusters means it internally, for suppose if you want to improve your performance in the SQL Server, what you need to increase? You have to increase the RAM, mean memory, and the CPU, means the disk space, right? So you should have those the two things, right? So sometimes if you are performing operations on the disk, so there might be kind of the input output will be operations will become slow. So for that matter, so within the Databricks, so we will be using these Spark clusters. These will be kind of in-memory process. These will be kind of using the in-memory processing. In-memory processing means every operation that you write, every transformation that you write, that will be performed and transformed within the memory itself. It will not use the disk. So that way, it will improve the performance of the input and output operations. And the flexibility with this is, so if you install the SQL Server, you will be able to use only SQL Server, right? Once you create the cluster and once you creating the notebooks on top of that cluster, so you will be choosing which language that you want to use in the notebook to transform the data. So either you can use Python or R language or Scala and SQL Server. So most of the times people use Python, Scala and SQL. Python means PySpark. It will be integrated with the PySpark. So we will be using PySpark and SQL. That is the most commonly used in the Databricks projects, right? And secured means, so how it is secured, everything that is that we do, the kind of security like role based security or any security that we implement, so that directly integrated with the Azure Active Directory, right? So and here we can restrict the access to the different components like notebooks, clusters and jobs and everything. So we can implement role based security and we will restrict the access to the Databricks. And scalable means, for suppose today you got only 10 MB data and you are expecting 10 MB data, but all of a sudden you got 1 GB data. But you have provisioned the cluster to include some of the RAM, right? So, but all of a sudden that 1 GB data is coming in. So generally, it will get timed out or it will throw an error like out of memory issues. But in Databricks, so depends on the workload, it will automatically auto scale itself. Auto scaling means if you enable the auto scaling, so the cluster size may increase. Internally, it will increase the number of worker nodes that are associated with the cluster. And so the since it is auto scale, I mean since we implement the auto scaling, so it will basically improve the performance and without any issues as well. So depends on the workload, it will provision the different worker nodes and everything. So it will improve the performance internally, right? So because of these reasons, because of these flexibilities, so we will be using the Databricks nowadays in most of the projects. So people started using Databricks. That's why if anybody attending the calls, so people started asking, do you know Databricks? Even though you didn't mention in your CV, so they will ask, do you know Databricks? Do you have a knowledge on Databricks? Now, in the Databricks, so these are all the key components that we are going to discuss in future. So the key components are like clusters. As I mentioned, cluster means, for suppose you want to run some you have created the cluster and you want to write some SQL code. Okay. So after creating the cluster, you can choose which language that you want to use, right? And clusters are, without clusters, you are not able to run any program or any transformations within the notebooks. First, you should create the clusters. Clusters means it will allocate the resources to do the in-memory processing. It will allocate the resources like memory, and you with after creating the cluster only you will be perform anything. So, and libraries means some of the third party libraries or jar files that you will import within this library section, right? And jobs. So if you once you created the notebooks based on some clusters, so you want to run them on daily basis. So for that, you will be creating the jobs and you will schedule that notebooks to execute on daily basis, right? And notebooks means we will write a we'll create a notebook. Within that we can write some programming within PySpark or Spark SQL, right? And workspaces means so within the workspaces you will save these notebooks and you will enable the branching strategy that we will see in future. So where you will save your code, and using these workspaces we can move our code from one environment to other. So these are all the key artifacts that we have in the Databricks environment. So this Databricks is on top of Spark architecture. So initially, Spark is the organization where it introduced the in-memory processing. It introduced the cluster concept. So in the within the cluster, it will do the in-memory processing. In-memory processing. So when we write any program within the notebooks, so how it will be distributed? When we write any program, so it will route through cluster manager. First, it will go to the cluster manager. This cluster manager, within that cluster, it will divide that workload into different worker nodes. Different worker nodes, right? So within the worker node, each worker node will have some kind of cache, and it will divide that into different tasks within the worker nodes. Tasks within the worker nodes, and then it will basically try to gather that output and then send it to back to the driver program. So first it will divide the workload and then send the uh, divide that workload into different worker nodes internally, and these worker nodes process the data, process the transformations, and then it will give the response back to the driver program. So while processing, it will internally what will do? It will connect to the data sources, okay, and then it will try to extract the data and try to process it, and then it will basically try to load the data into the different destinations, right? This is the kind of a internal architecture of the Spark, right? So that's why you will hear the terminology called as Spark architecture or Spark cluster. So this is the Databricks is built upon this Spark architecture. Because why it is built, why we can say it is built upon Spark architecture? Because the Spark architecture is like this, and when we write any programming within the Databricks, so it will be sending that response back to the cluster manager and to the worker nodes, and the worker nodes will be processing our data and do the transformations, and it will be kind of um, connecting to the different resource data sources, and then we will basically send the response back to the driver program. So that's why we can also see the terminal is like Spark architecture or Spark cluster. So why Spark? I mean, why it is advantage? Like why this Databricks is built upon Spark architecture? So generally in the disk, if you want to perform anything, right? If you want to perform anything, right? So within the disk, what we will do? it will kind of for the input and output operations, like for suppose extracting the data or transforming the data and sending the data back to the destination. So these are all kind of input and output operations in the disk. So you have to depend on multiple like the CPUs or kind of the architectures. So because of internal architecture, it will slow down the performance. So when because it will be kind of trying to divide that into like many small iterations, so it will slow down the performance. But when we go for in-memory processing, so the data will not be divided into small partitions. That partitions will be less and the response will be good. So that's why in order to increase the performance of the input output processing, so we will do the in-memory processing. So the Spark is built upon in-memory processing. So that's why we have replaced the disk with the memory in the Spark architecture. So the disk is a kind of traditional one. Though now in modern cloud architecture, most of the tools are doing the kind of in-memory processing because the input and output operations will be faster. Input and output operations will be faster. So next thing is, so as I mentioned, so in-memory processing, so we can avoid disk input and output, and we can gain the Spark distributed execution engine. So that will improve the performance of the different transformations. Now, this is a kind of overall how it looks like. So here we will use different APIs like R language, SQL or Python, Scala. You can use Java also. You can use multiple languages. And of course, we can use multiple data sources to connect to the Databricks and bring the data from. And also we, along with batch processing. Batch processing means when we do some operations using Spark SQL plus PySpark. So that is kind of batch processing, using which we can also, using the Databricks, we can streaming the data. Streaming the data means whenever any record inserted into the source, then on top of them immediately we will do the processing and we will showcase to the business, or we can load it to the destination. That is called as streaming. So live data. So we can perform both batch processing and streaming using the Databricks. And of course, nowadays you can hear the terminology called as kind of machine learning. So we can, within the Databricks, we can also use different machine learning algorithms, and we can fine tune the data, and we can predict the future based on the past data. So these are all the features that we can use and utilize in the Databricks. So most of the times we'll be using SQL and the Python, and we'll be using kind of Spark SQL and data frames, blah blah blah. So overall, so what are the features that because of which we are using Databricks? First most advantage is clusters, because clusters will basically do the in-memory processing that will reduce the input and output processing. And as I mentioned, auto scaling means we can scale up or scale down automatically, depends on the workload. And also we can use, it is integrated with the different programming languages, as I mentioned. And we can it will have the interactive workspace. If you want, you can also visualize the data in the Databricks. I will show you, but that is not required for our course or BI work. But that we will see one example how we can create visualizations in the Databricks also, right? And as I mentioned, it is secured because it is, I mean, we can create role-based access. We can create the roles like read, write, or admin, and we can give the permissions to the required users based on certain rules, right? and it is integrated with the different Azure services. Like we'll be kind of using SQL data lake most of the times and blob storage. And also we can integrate with this Power BI also if you want it. And coming to this Databricks, how to set up our free trial account. So we can create two types of trial accounts. One is the trial accounts like Databricks platform, the free trial account that we can create, and we can create the community edition. So if you, I will just break down here. So I will try to show it to you the difference. So Azure, if you type in Azure Databricks community edition, sign up. So this is, if you just type in, so it will give this. This is a kind of a, when you are trying to create the community edition, it will give like this. It will give the like this. So you can enter your first name, last name, email ID, phone number, and just click on continue. So your community edition and the trial account will be created. So it will be lost within 14 days. I think it's 14 or 15 days. Once it is expired, then again you have to create one more account for practice purpose. Okay. So this is for free only. So they will not charge you anything. And also you can, if you have the Azure trial account, if you already have the some people have created the trial account. So within that, you can also try creating the Databricks. But I'm not sure whether it will support in the trial account or not. If not, you have to create the community edition for the Databricks. Okay. If they are not allowing you to create some Databricks notebooks and all, so you have to basically try to create in the community edition. The community edition. Okay, just type in Azure Databricks Community Edition and just click on Community Edition login. So this will take you to that window, and you can, if you already created this Community Edition login, just you can log in every time. Okay, if you want to do the sign up, so just type in sign up. So it will take you to do the sign up. Okay, so like this window will be open, right? So this is the story about this account creation. Okay, so don't worry, we'll be creating this tomorrow. In the next class we will be trying creating this, and we will see what are the options that we'll have again. Okay, and so this is the whole story, about the Databricks architecture, and what are all the language that we'll use, and kind of we know like it is built upon Spark architecture. We kind of got a introduction to Spark, cluster, like how it is internally distributed. So when we write any program in the notebook, so it will be route through cluster manager, and it will divide the work into different worker nodes. So because of these reasons, right? So we will be using the data bricks. Okay. So this is a kind of overall introduction about the data bricks. So nowadays, like most of the companies asking the combination of SQL Server, ADF, and Databricks. So Databricks means anyway they assume like PySpark or Scala. Okay, at least you should know one language. Most of the projects I observe, we are using PySpark. Very rarely we will be using the Scala. Scala, if you know the spice part, Scala is very easy. On the fly, you can learn it, right? So, ADF, actually, this current batch I already covered ADF and SQL. This is a continuation database. The people who are only joined for Databricks, okay, no issues. So if you know the SQL, that will be good. But if you don't know, I suggest you to brush up your SQL server skills, right? At least basics, because I will not again cover this SQL server topics, because I straight away correlate the transformations that we are doing with the SQL anyways, but I will not go depth into that. Okay, so that you have to remember. Okay, so if you have any queries, you can ask now. So from tomorrow onwards, we will see how to create the trial account, what are all the different things that we can do, and then we will try to go depth into the PySpark and the database.